see who will be eliminated from the race tonight.
No, not that type of elimination, you silly. Linear algebra elimination.
Oh!
But before looking at the cool elimination in the world, we need to understand matrices and vectors. We all know the standard xy plane. We can plot points and lines. Now what about vectors? Multiplying vectors to other vectors is less intuitive. We use what's called the dot product. We multiply each component and then add the result to get a number. Now what if I were to take these two vectors, which only meet at the origin, and take all their linear combinations? I would get the entire xy plane. But if these vectors are combinations of each other, meaning they are dependent, I would only get a line in R2. Independence will become really handy for when we perform elimination. We can combine two or more vectors to get a matrix, but it is crucial to note that matrix multiplication is not associative. Every entry of the product is a dot product of the matrices it is a combination of. So row I, column J of the product is a dot product of row I of A and column J of B. Matrices are just like equations. Just like a system of unknowns in linear algebra, we're trying to solve for x. To do so, we need to eliminate. Take this example. We can subtract 2 times row 1 from row 2. Then we can add row 1 to row 3. Now we have eliminated the first column. Then we can add row 2 to row 3 to reach an upper triangular matrix with what are called pivots in the diagonal positions and zeros below it. We need the zeros below the pivots in order to reach an equation with only one unknown. If any zeros are in the pivot positions, elimination breaks down. But if we reach a nice matrix, then we can perform back substitution to solve for x by plugging the coefficients back into the equation and doing some good old simple algebra. So why does this matter? Elimination and linear algebra are crucial to everyday life. I mean, Netflix, Amazon, and Google use machine learning in their sorting systems, and linear algebra is the foundation of machine learning. So the next time you're watching The Amazing Race, just ask yourself, does that team have zeros in the pivot positions? If so, then they might get eliminated.